Hello everyone, welcome back to this channel. We are studying class 9 science in that chapter number 9 force and laws of motion. So today in this video we are going to explore all the blue in text question from this chapter. As in the previous video we have already completed all the topics. So let us start with the first question, that is, which of the following has more inertia? There are three different questions, so we will have an answer for each. First is a rubber ball and a stone of same size. Now we have to remember that inertia is directly dependent on or related to the mass of the object. So the more the mass, the more will be the inertia. The less the mass, the less will be the inertia. So in the first case, a rubber ball and a stone of the same size, as you can see, the stone will have more inertia because it has more mass than the rubber ball. In second, bicycle and a train is compared. Obviously, the train is heavier, so it will have more mass, so it will have more inertia. And third one, a 5 rupees coin and a 1 rupee coin. We all have seen both the coins, and we know that 5 rupees coin is more heavy, that means having more mass. So 5 rupees coin will have more inertia. Moving ahead to the next question. Next question is very interesting. In the following example, try to identify the number of times the velocity of the ball changes. So one case is given in which we have to write down that how many times the velocity of the ball is changing and identify the agent supplying the force in each case. Okay. So now let us read the lines, and one by one we will see how many agents are there and who are those and when the velocity of ball is changing. So a football player kicks a football to another player. That means the first agent is the football player, and here the ball was at rest and now he is kicking the football, so ball, the velocity changes. Now second will be the another player of the team. He will get the ball and now he will kick the football towards the goal. So second time the velocity has changed. Now the goalkeeper of the opposite team collects the football. So here the velocity changes toward the third time and by the goalkeeper, and now the fourth time, that is the foot kicks it towards a player of his own team. So here the goalkeeper again is the agent and now he's kicking the football towards a player of his own team. So you can see there are many different agents and four times the velocity of ball is changing. So I have that represented that in terms of a table. First player kicks a football, so first time velocity changes. Second player kicks the football towards the goal, second time the velocity changes. Goalkeeper collects the football, so third time the velocity changes, and goalkeeper kicks towards his team player, so fourth time the velocity is changed. So this is how you will answer this. Moving on to question number 3. Explain why some of the leaves may get detached from a tree if we vigorously shake its branch. So now here we will again recall the concept of inertia. Before we vigorously shake or touch, even the branch as well as the leaves were in state of rest. Now what will happen if you are just shaking the branch vigorously? The branch will leave its motion or leave its state of rest, but the leaves will always try to stay at rest. So what will happen? The branch will move, leaf will remain as it is. As a result, it will detach and they will fall down. Clear? Moving on to the next question. Why do you fall in the forward direction when a moving bus brakes to stop and fall backward when it accelerates from the rest? So two cases are there. These both the cases with animation video and explanation I have shown in my video of inertia. You may use it for this answer. Now let us see what happens over here. First case is a moving bus will stop. So here what will happen? We will fall in forward direction, right? You can see in the picture. So what we can write, when the bus is moving, our body is also in motion. But if sudden brake is applied, the lower part of our body comes to rest, but upper part will continue motion. So we fall forward. Now second case, when the bus will accelerate from rest, we will move backward. Why? Because When bus was stationary, we were also stationary. When the bus accelerated, only our lower part accelerated and moved forward. Our upper part remained stationary, so we fell backward. So case wise and representing in diagram wise I have shown. So this will be the answer. Moving on to the next question. If action is always equal to reaction, explain how a horse can pull a cart. Here the question seems to be little bit incomplete because they are only comparing the horse in forward direction and cart in backward direction, right? So if you will see only these two forces, they will always be equal, but don't forget that horse will apply more force because the cart will have some inertia as well as friction, but to overcome that the horse is applying more force. Same way, horse is also applying force on the ground, right, at an angle with its feet while walking. So what happens, the ground also exert an equal and opposite force on the feet, and due to this the horse will always move forward carrying the cart. Clear? So that is why this question knowingly they have given incomplete, but we have to take care of all the forces which are acting over here. Though it is force of friction on this side, the weight, the inertia of cart is there, the horse is moving on the front side, he is applying force, but again there is some friction between the feet and the ground which will help the horse to move forward and pull the cart. Clear? Now second question is, explain why is it difficult for a fireman to hold a hose pipe which ejects large amount of water at high velocity. So here we will use the concept of third law of motion as well and change in momentum as well, right? You can see the water that is ejected out from the hose pipe in forward direction comes with a large momentum, right, mass as well as velocity, right, and it moves in forward direction. So equal amount of momentum is developed in the hose pipe in the opposite direction as action. This is action, so the backward movement will be considered as reaction and the hose pipe will be pushed backward. Now this fireman has to hold the hose against the force of action and reaction. So it is very difficult that he will hold it very easily because of the momentum. Because of the action and reaction, he has to apply little bit more force in holding the hose pipe. Clear? Now third question, the next question is, from a rifle of mass 4 kilogram, a bullet of mass 50 gram is fired with an initial velocity of 35 meter per second. Calculate the initial recoil velocity of the rifle. Now, this is based on law of conservation of momentum. We will consider the momentum, initial momentum before firing and after firing, right? So before firing the bullet and the rifle or the yes, rifle was stationary, so zero momentum they had, and after firing they gained some momentum. So before firing and after firing, we will let us start with the given list. Mass of rifle M1 4 kilogram, mass of bullet M2 50 gram only, so convert it into kilogram 0.05. Velocity of bullet, that is after firing, V2 is 35 meter per second. Recoil velocity V1 that we are finding. Initial velocity U1 U2 is both 0 meter per second. Now according to the law of conservation of momentum, total momentum before firing is equal to total momentum after firing. That is, initial momentum of this rifle plus bullet equals to final momentum. So M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Now putting all the values, as initial U1 U2 is 0, whole term on the left hand side is 0. M1 is 4, V1 is V1, M2 0.05, V2 is 35. So if you solve this, 0.05 into 35 is 1.75. Let us take 1.75 to this side, so it will become negative. So ultimately we will be left with 4v1 equals to minus 1.75. So 4 we are taking downward, so minus 1.75 upon 4 is 0.4375, that is negative. Why it is negative? Because once the bullet moves forward, the recoil is opposite, right? So if bullet is in positive direction, recoil will always be in negative direction. Clear? Now, seeing the similar type of question in the last one, two objects of masses 100 gram and 200 gram are moving along the same line and direction with velocities of 2 meter per second and 1 meter per second. So this is the initial thing. Now what happens? They collide, and after the collision, the first object moves at the velocity of 1.67 meter per second. So we have to just find out the velocity of second object, right? So again, there will be two cases: before colliding, after colliding. So let us make the given list. Before collision, M1 100 gram, 0.1 kilogram, M2 200 gram, 0.2 kilogram, U1 2 meter per second, U2 1 meter per second. Now after collision, what happens? Mass will remain the same, so no need to write again. M1 M2 will be same, but V1 and V2 will be different. So first object we have 1.67 meter per second. Second object's velocity we are finding. So question mark. Now, using the law of conservation of momentum, m1u1 plus m2u2 equals to m1v1 plus m2v2. Now, putting all the values, you see m1 is 0.1, u1 is 2, m2 is zero point 0.2, u2 is 1. Here on this side, m1 is 0.1, v1 already given 1.67, m2 zero point 0.2, but v2 is not given. So v2 will remain as it is. Now if you solve both these, zero point 0.1 into 2 is 0.2, 0.2 into 1 is 0.2. Over here, zero point 0.1 into 1.67 gives 0.167 plus zero point 0.2 v2. So what will be the normal form? We will add these two, so becomes 0.4, and take this on the other side minus 0.167, and to find v2 we will have to do this zero point 0.2 moves over here and goes in the denominator. So finally we have the value of v2 as 1.16 meter per second, right? So after simplification you get this value. This question will appear tough because there are small values as well as decimal, but if you have to follow this law of conservation of momentum, it will be very easy. So that's it for this video. We only have this much blue question, in text blue questions, and in the next video we will solve and see the solution of exercise question. So till then, write this properly and make proper notes.